All right, so we're going to apply all these ideas to a question, and hopefully a question that maybe is difficult for you, or at least one that you're not sure how to approach. In my experience last year, students were okay with applying the idea of concavity and increasing, decreasing intervals to like cubic functions, quartic functions, like polynomials that were fine. But then students got stuck when they had to deal with functions that were not polynomials, or, so I'm trying to give you as many kinds of questions like that as possible. I gave you some trigonometry questions earlier, some exponential functions. Today I'm going to give you a natural log function, and we're going to deal with that. This is where calculus becomes a little bit challenging. It's challenging because it's not so much the calculus that you're learning, it's that you have to rely on a really strong foundation and mastery of previous content. So here, when we're in calculus, the further and further you go in calculus, the more and more you're going to have to rely on information that you've learned in the past, like DP semester 1, semester 2, and that's what students find most challenging about calculus, is everything becomes very tightly connected. Okay, but just feel free to look back at your notes and work things out. It's okay to forget things, but do look up the concepts when you're not sure, or ask me or someone in your friend group to help. Okay, so this question is going to be multiple parts, and part A says determine the domain of this function here. This is, again, relying on something that you learned in semester 1. In semester 1, we talked about the domain of natural log functions. The domain of natural log functions is when the argument is positive. Okay, so 2x minus 1 has to be positive. So I'll say 2x minus 1 has to be positive. That means x has to be bigger than 1/2, okay, if you solve. So we can say, therefore, the domain of f is going to be x values bigger than 1/2. Okay, and that's it. Okay, part B says find any intercepts. Okay, so it doesn't really tell you x-intercepts, y-intercepts. It just wants all intercepts. Okay, so let's first find the x-intercept. Okay, so at the x-intercepts, the y value is equal to 0. And because the y value is equal to 0, we can say 0 is equal to the natural log of 2x minus 1 minus 3. And so that means the natural log of 2x minus 1 is 3. And that means, and here, maybe I'm going to actually erase the natural log, write natural log as base e, okay, because that's what natural log is just logarithm base e. And then you have to kind of put this into exponential form, okay? So log base e of 2x minus 1 equals 3 means 3 is the exponent on e to get to 2x minus 1. Okay. And so if you solve for x, you get e cubed plus 1 by adding 1 to both sides, and then you divide by 2, and that's your x-intercept. Okay. So I guess you could say, therefore, the x-intercept is. Usually it's good to give it as coordinates, but I suppose with intercepts you can also just give the value, but I think it's nice to just give the coordinates if you can. Okay, so that's our x-intercept. A couple things. Number one, you can already see that this relies on previous knowledge. As soon as you're finding the x-intercept, you're solving a logarithmic equation, so that's relying on things that you learned in the logs unit, like in semester 1. But I could have you solve a trigonometric equation or an exponential equation, or a rational equation. And so part of what makes calculus difficult is you need a mastery of previous concepts, okay? And hopefully you'll build that mastery slowly over time. Okay, a couple things. Some people don't, they get confused from this step to this step. Another way to think about it is, if you want to, you don't have to, you could raise both sides to the power of e. So if you raise both sides to the power of e, you get e to the power of log base e of 2x minus 1 equals e to the power of 3. And then you can apply your log property. E to the power of log base e of, anything is just that thing. Okay? And that's one of your log rules. So, yeah. I don't know if that helps or makes it worse, but that's another way to look at it. Okay. Now, what about the y-intercept? The y-intercept, it turns out that there is not going to be a y-intercept. And this is where you have to think through the problem carefully. Look at the domain. The domain is x values larger than 1/2. So if your number line is here, you know, this is your number line, and your y-axis here is the line x equals 0, really, our domain is x values larger than a half, right? So there's no way you're going to have a y-intercept, okay? So you could just say since the domain of f is x values larger than a half, there is no y-intercept. Okay. All right. Pause if you need to. I'm going to move it down. Part C says, explain why the function f of x is increasing for all x in the domain of f. Okay, so this is just notation to say x belongs to the domain of f. Okay, the domain of f being the set of real numbers bigger than 1/2. They want you to explain why f of x is increasing for all x values in that domain. Okay, these are kinds of questions that students had trouble with last year. I think part of the reason they had trouble was the word explain is misleading. If you're in English class, explain probably means like provide an explanation, like in English, using sentences. But in mathematics, the word explain just means just justify your reasoning and just justify it using mathematics. Okay, so it's okay to do that. So if f of x, if they want us to show that f of x is always increasing, really what they want us to show is that they want us to show that the first derivative is always positive. Because remember, we talked about this last time, but first derivative being positive or 0 means the function is increasing. If I can somehow show the first derivative is positive for all these x values, then I'm showing that, you know, the function is increasing. Okay, so let's go back. I'm just going to copy down the function, and then we'll get started. Let's grab this. Okay. So I'm just going to copy down the function, and then because we want to show that the function is increasing, we need the first derivative. Here I'm relying on some understanding of how to take derivatives. Okay, the derivative of a difference is the difference of the derivative, so you can kind of deal with those separately. The derivative of a natural log function is 1 over the argument. Okay, so it's going to be 1 divided by the argument, which is 2x minus 1, multiplied by the derivative of the inside function. Okay, inside function is the linear function 2x minus 1. The derivative of negative 3 is just 0 because negative 3 is a constant. The derivative of 2x minus 1 is 2 because that's the slope of the line. And so here is our first derivative after being simplified. Okay, what we need to do is we need to explain, or at least justify our mathematical thinking and show that this function is always increasing, at least within the domain. Okay, and you can do this many ways. I'll show you 2 different ways. One way is to just do it algebraically, and I'll show you what that looks like now. And another way is just to make a sign chart. If you just make a sign chart, that's enough of an explanation. Okay, so here they're just asking you to explain. So what I'm going to do is do it kind of algebraically. And what I'm going to say is 2x minus 1 is bigger than 0. Okay, so I'm making a claim about whether something is positive or negative. In this case, I'm making a claim about something being positive because I want to show that f of x is increasing. And this 2x minus 1 is really just the denominator here. If I can show the denominator is positive, then really I can easily show that the ratio is positive because 2 is always positive. I just need to show that this thing is positive. Okay, so 2x minus 1 is positive for all x values. Now, so far this is not true, okay, because 2x minus 1 can be positive or negative. But if I just stick a x larger than 1/2, then I'm safe. Okay, so as long as the x values are larger than 1/2, okay, as long as this is true, then 2x minus 1 is positive. Okay, well, from that I can conclude, well, therefore I can say 2 divided by 2x minus 1 is also positive, right? Because here it's just a ratio of 2 positive quantities. That's also positive. And then from there I can conclude, therefore, f prime of x is always positive, at least for all x bigger than 1/2, it's positive. Well, I mean, if f prime of x is always positive, that means that the original function must have been increasing for all values of x larger than 1/2. So for all values of x in the domain of the function. You say, therefore, f of x is increasing for all x values in the domain of the function. Okay, and that's enough of an explanation. In fact, that might be more than what you need. But I think there are some things that you need. You need to demonstrate that you understand why something is positive. Show that the derivative is positive. Connect that to the fact that the function is increasing. I think some elements of everything need to be in there. Okay, the next part D says, explain why the function f of x is concave down for all x values in the domain of f. Okay, so here what they're saying is, show me that or explain that, why is the function always concave down? And because it's talking about concavity, you're not going to need the first derivative, you're going to need the second derivative. Okay, so first let's just go ahead and copy down the first derivative. So the first derivative is right here. I'm just going to copy it down. So f prime of x is 2 divided by 2x minus 1. Now here, what we're going to want to do is find the second derivative. Find the derivative of the derivative, because we want to show concavity, or we want to show something about concavity. Now you might try to do quotient rule here, because it's a ratio of two polynomials, I suppose. But I think that's the long way of doing things. Part of what I want you to think about as you're doing calculus is, what's the most efficient path through the question? Here, the most efficient path is to rewrite the 2x minus 1 with a power, like -1 power. And then once you write 2x minus 1 with a negative power, you can just apply chain rule. Okay, so here you have an inside function, 2x minus 1, and then the outside function is a power function. The constant you can just kind of leave in the front. Okay, so you just have 2 times. Okay, the -1 will come down. So -1, leave the inside function alone. And you subtract 1 from the power. And then you have to multiply by the derivative of the inside function. The derivative of the inside function here is 2. Okay. So in total, we have 2 times 2 times -1. It's -4. And then we also have divided by 2x minus 1 squared. Okay. Now, we have to show that this is always concave down. Okay. Or at least explain. Well, the question says to explain. If the question says to show, I think it's better to show using this kind of reasoning, like use some sort of algebraic reasoning to show that it's concave down. And I can, we can do it that way as well. Here, the question just asks you to explain. It's enough to just make a sign diagram. So you could just say something like f prime of x has a sign diagram or sign chart, whatever you want to call it. I think the textbook calls this a sign diagram. So you could just say f prime of x has the following sign diagram. Okay, so we just make a number line. And then on the number line, I'm going to mark in 1/2. Now to the left of 1/2, I actually don't care. So my diagram is actually not a good diagram. The function's actually undefined. To the left of 1/2 and at 1/2, the function's undefined. And then the second derivative, let me do that again. So put the second derivative here. The second derivative, if we try a value of x that's larger than 1/2, maybe like 1, if you plug in 1 into here, the denominator is going to be positive, of course, because it's a square. And then this is going to be negative. Okay, so it really doesn't matter, because anything that you're going to plug in a number bigger than 1/2 in here, that's always going to be positive. Square of that is going to be positive. -4 divided by a positive number is going to be negative. Okay? So you can say the following. Therefore, f prime of x is less than 0 for all x bigger than 1/2. Therefore, f of x is concave down for all x larger than 1/2. Okay? And so hopefully it's clear how you have to explain and how you have to show these things. Now, if the question was a show question, I would probably just say something along the lines of 2x minus 1 is larger than 0, like it's positive if x is bigger than 1/2. and then show that the square is positive, and then negative 4 divided by that, will be always negative. Something along those lines, okay? Here it just wants you to explain. I think a diagram, actually, I don't think, I know a diagram is sufficient, okay? So that's fine.